Hi everybody, welcome back to my YouTube channel. If you like the video, make sure that you comment below and like and subscribe. Just kidding, I could never be a YouTuber. All right, we're gonna do a couple of videos today. The first one is gonna be very short, very cut and dry. I just want you guys to have an understanding of how to make sure a number is written in scientific notation. What I mean by that, if I gave you this, you already know this is written, this is standard notation. You know how to write it in scientific already. We've already done that. Your coefficient is going to be 3.23 times 10 to the 1, 2, 3, 4, 5 times 10 to the 5th. Okay, I'm not worried about that part, you know it. What I do know is concerning is, let's say that you get a number written like this. 36 times 10 to the 12th. You may see this and think it's scientific notation, but those of you who remember the pieces of scientific notation know that it's not, because this coefficient, this 36, is too big, okay? 36 is bigger than 10, and you know that your coefficient in scientific notation has to be greater than equal to 1 or less than 10. So this is too big, okay? So there are a couple of ways that you can fix it, for lack of a better term, make it into scientific notation. There's the easy way, where you can go ahead and make this standard. So my decimal point, remember, if it's a whole number, is always behind the number. That's why I know it's 36, because the decimal point's back here. From where this decimal point is, I'm going to move it 12 spaces to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Take my decimal point out, put it at the end, put zeros in as my placeholder. Okay, then I wrote it in standard. Now I'm going to take this number and put it back into real scientific notation. So I'm going to use 3.6 as my significant digits. From here, I have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places. Now, this one is correct scientific notation, because this coefficient is between 1 and 10, and it's a power of 10, okay? Now, you can see similarities between these. I'm going to erase this square just because I feel like it's making my numbers feel kind of all over the place. Let's compare these two for a second. In this first one to the second one with the coefficient, I took my decimal and I moved it over 1, because down here it's between the 3 and the 6, okay? So I moved it 1 to the left. I moved it 1 to the left. When I moved it 1 to the left, my exponent went up by 1. I added 1. So the trick, for lack of a better term, if you don't want to, or if you don't have the time to expand it and then put it back in scientific notation, just remember every move to the left adds 1 to the exponent, or probably more realistically, every 1 you add to the exponent moves your decimal to the left. And remember, it's because we talked about how this base 10, the number of zeros in this power of 10, are what moves the decimal point. So if I add a 0 to this decimal point, it's going to move again. Or if I add a 0 to this power of 10, okay? So every time you move 1 to the left, you add 1 to the exponent. So I could even, if I wanted to, I wouldn't because this isn't scientific notation, but I could even take it further and move this 1 over and make it 0.36 times 10 to the 14th. All 1, 2, 3, 4. All 4 of these values are equal. All of them, if I put it into a calculator, equals this number right here, right? The only one that's written in scientific notation is this one, okay? That's it. You just need to remember, if it's a negative, it's the same. It's the same concept if it's a negative number. So for example, let's say that you solved a problem and what you ended up with was 32.3 times 10 to the negative third. Well, I know I'm going to need to pull this over between the 3 and the 2, 3.23. Every time I move my decimal place over 1, I add 1 to my exponent. Negative 3 plus 1 is negative 2. When I move it to the left one, I add 1 to my exponent. Conversely, which means opposite, whenever I move it to the right, I subtract 1. So if I've got 0.34 times 10 to the 5th, I can expand it, take this, move it over 5 places, okay? So I'm going to go ahead and do that. It starts here, you move it 1, 2, 3, 4, 5, and I've got 34,000, okay? But this isn't scientific notation. For it to be scientific notation, it's got to be between the 3 and the 4. So I'm going to move my decimal 1 place over to the right. From here, it's only going to take me 1, 2, 3, 4 places. So this is this number written in scientific notation. So if I move my decimal to the right, you subtract. One from the exponent. Okay, so every time you move a decimal point to the right, you subtract 1 from the exponent. Every time you move it to the left, you add 1 to the exponent. Okay, just a small little minor important thing for you when we start the next thing, which is going to be multiplication and division.